Dear students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, B.V. Raju Institute of Technology, Narsapur. In this linear algebra and calculus course, today we are going to see second example on maxima and minima without constraints. Let us take the problem statement. So the problem statement is, find the maximum and minimum values of and minimum values of f of x comma y is equal to x cube plus y cube minus 3axy. Right? So whatever the given function, you can take as f of x comma y as x cube plus y cube minus 3axy. So in order to compute the maxima and minima for this function, we have to use the sufficient condition for a function to admit either maximum or minimum is first order partial derivatives should be 0. First of all, we have to compute dou f by dou x and put equal to 0. So we are going to get here x cube derivative is what? 3x square. Y cube is independent of x, therefore it's treated as constant derivative is 0. Minus 3 constant, a constant, y constant, and x derivative with respect to x is given by 1 and put equal to 0. From this, take 3 common and send it to the other side. You are going to have x square minus ay is equal to 0. This you label as equation 1. Similarly, compute dou f by dou y is equal to 0. So from this you are going to get 3y square minus 3ax is equal to 0. And take 3 common, you are going to have y square minus ax, y square minus ax equal to 0. This implies y square minus ax is equal to 0 and label as equation 2. We have to solve equation 1, 2 and star to compute the stationary points. So let me take this 1 and 2, subtract one from the other, or you take one variable from equation 1 and substitute into the other. So from 1 we have x square is equal to ay. This implies y is equal to x square by a. So substitute this into equation 2. Therefore equation 2 implies you are going to have y square is nothing but x square by a, x square by a whole square minus a times x equal to 0. So on simplification you are going to have x power 4 by a square minus ax is equal to 0. If you take LCM, you are going to have x power 4 minus a cube x is equal to 0. Again, if you take x common, it remains x cube minus a cube is equal to 0. So from this, you are going to have either x is equal to 0 or x is equal to a. So when x is equal to 0, from the relation y is equal to, previously we got one relation as y is equal to x square by a, this one. From this, y equal to x square by a, when x is 0, y is also 0. When x is a, y is equal to a square by a, nothing but a. Therefore, stationary points are 0, 0 and a, be the two possible stationary points. Now, at each and every stationary point, we have to compute the sign of ln minus n square. Now, let us take the definition of L. Dou square f by dou x square, nothing but dou by dou x of dou f by dou x. From equation 1, we have x square minus ay as dou f by dou x. and compute the derivative of this with respect to x, you will get 2x. This term minus ay don't have any x term treated as constant derivative is 0. Similarly, let us compute n. So derivative is given by dou square f by dou y square. Nothing but dou by dou y of y square minus ax. This is from equation 2. So its derivative is given by 2y. And finally, we have to compute m. M definition is given by dou square f by dou x dou y. From this dou by dou x of dou f by dou y, that is nothing but y square minus ax. So upon differentiating this partially with respect to dx, y square derivative is forced to 0 and minus a is constant, x derivative with respect to x is 1. Now after computing ln m, now let us compute the expression for ln minus m square. Therefore, ln minus m square is equal to 2x multiplied with 2y minus a whole square. This is given by 4xy minus a square. In this, we have to check the sign of ln minus m square at the stationary points. So first stationary point is given by 0, 0. At 0, 0, ln minus m square, we have 4 times 0 minus a square. It is nothing but minus a square, and its sign is given by less than 0. So therefore, from the working rule, if ln minus m square is less than 0, then f of x comma y has neither maximum nor minimum. In this case, 0, 0 is called as the saddle point. Now let us see the same sign of ln minus m square at another stationary point a comma a. So another stationary point is given by a comma a. At a comma a, we have ln minus m square is equal to 4 times a minus a square. It is 3a square, and 3a square is greater than 0. And L is given by the expression 2x. At a comma a, you are going to have 2 into a. So unless you know the value of a, you cannot say whether L is greater than 0 or L is less than 0. So therefore, ln minus m square is greater than 0 and L is less than 0 for a less than 0 and L is greater than 0 for a greater than 0. So therefore, f of x comma y has maximum at a comma a when a is less than 0. So when L is less than 0 and ln minus m square is greater than 0, function admits maximum value. And when L is greater than 0, function admits minimum value. So from this working rule, we are going to write f of x comma y has maximum value at the stationary point a comma a, provided a should be less than 0. And similarly, f of x comma y has minimum at a comma a when a is greater than 0. So, and if you want to compute, you can compute maximum and minimum for the function at the stationary point. F max at a comma a is given by x cube means a cube, y cube means a cube, minus 3axy means we are going to get 3a cube. It is given by minus a cube. And f min at a comma a also we are going to get the same value, right? So thank you for watching the video, and the next class we will see another example on maxima and minima without constraints. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.